We continue our lecture about the information system in the city or smart buildings or smart city, etc. What is the role, what is the task of an engineer in the city regarding the information system? As we know, there is a lot of models in the city, there is a lot of data, there are a lot of information about the city. So at first, as an engineer, we should know what is our city, what type of abstraction we need from the city. The city is a concrete systems, and we need to know what type of models we need to understand the city. It depends on our domain. So we should be able to understand the context, to understand the available information systems. We should understand the problem. So an engineer should understand and analyze the eventual structure of the city. He should understand the needs of the city, and he should understand the problems. So all these techniques are available, and we will learn some of them in this course. They are not, we need some training in order to be able to analyze, to make this abstraction. What is important also in the work of an engineer is to be able to discover always the new technology available in his domain, the new techniques, the new methods, and new algorithms. So the engineer should be able to know about the available technology and how to use it. For example, in our domain, there is a lot of sensors, there is a lot of communication systems, there is a lot of new techniques to analyze data that may be useful in our domain. After that, an engineer should be able to propose the solution. So basing on the available technology, on the available communication systems, on the previous experience of the engineer, or the previous experience of the users, he should propose solution. So an engineer should propose scientific solution, and he should be able to propose a system also. In our domain, he should be able to propose an information system. So he should participate. It depends in his domain. If he is an informatic engineer, he should be able to work more in the information system itself. He can develop the system, he can make the analysis of the system, he can make the design and the implementation of the system and the test of the system. If he is an urban engineer, he should be able to understand the system, to participate in the analysis of the system, and he should help to propose the solution. He should invent a new solution also in cooperation with the informatic engineer. Perhaps he should not be able, it is not a condition that he can implement the solution, that he can write code, but he should be able to at least to analyze the system and to participate in the design and to test the proposed system. This is in general the task of an engineer. In all the domain of engineering, always an engineer should be able to understand the model, the system, and he should be able to understand the difficulties, the problems, and to know the previous experience, the human experience in this domain, and to be able to propose new solution, or the propose the new structure of the solution. It should be scientific solution. What type of tools we can use? There is a lot of tools. One of the important tools in this domain regarding to the engineering work, it is UML, Unified Modeling Language. It is very important. Unified modeling language. It is a simplified language that use diagrams to communicate between engineers. In UML, we can modelize the activities in the system, and we can modelize the component of the system, and we can see the system from the outer view. So we have use case diagrams. With this use case diagrams, we can understand how the system is seen from outside, how the external user of the system see the system. For example, if we are in hospital, we can see how a patient interact with this hospital. What does he need from the hospital? And we can see from another type of diagrams, like activity diagram, for example, we can see how a specific task is executed. In a class diagram, it is related also to UML, we can see the component of the system and the relationships between these between these components. In DFD diagrams, the data flow diagram, we can see how the data is following. We can see the flow. We can follow the operation in the system. We can see how the data come from the out of the system and come in the system, and how the data is treated, and what type of output the system can give as data. So in DFD we can follow, for example, the file of a student. When we register in the university, we can follow how the student, how we get the information, how we register this information, how we treat this information, how we prepare for the examination, how we get the results, how we can say that a student is graduate, etc. So we treat the data in DFD. We can see better how data is treated in the system. What type of tools we need also? There is another type of tools, as you see. We should know a lot about the available sensors in this domain. The development is very speed in this domain. So there is a huge quantity of sensors. Now there is temperature, humidity, CO2, CO. We can measure a lot of types of gases. We can measure temperature, as I said, the speed. There is many hundreds of measurement that we can do, but we should know what we need exactly, because each sensors has its precision, accuracy, and it has also its own price. So it is a question that is related to the needs and the available money. It is related to the cost and what we need. By the time the prices of the sensors are decreasing, and for example, we used 3 or 4 years ago CO2 sensor. It costed almost 300 to 500 euro. Now I buy the same sensor with the ability to measure another type of parameters for only 100 euro. So it is a question of cost, of needs, and we should preview the future also of our needs when we design a system. So an engineer should understand, analyze using UML, DFD, etc. He should also know about the available sensor in a system, what we need for a system, available technology. He should know about the protocols of data transmission. Nowadays there is a lot of protocols. Everybody know, for example, the Wi-Fi. We know Bluetooth. We use, everybody when he go to, for example, in the metro station, he use a card. We use a type of communication protocol when we buy from a supermarket, when we use the card, a credit card or other type of cards. There is a lot of communication protocols for short distance and for long distance. There is a variety of protocols with different type of securities. We should know, an engineer should know what are the available technology concerning the communication. For example, we use what we can call LoRa. LoRa technology, it is a new technology that enable to communicate between sensors and a station, a gateway, and it can communicate for 1, 2, 3 till sometimes 20 kilometers, and it is with very cheap cost. So we should know about the available protocols of communication. We should know about the data storage. We have now a lot of sensors. We should now, even most times the quantity of data that a sensor give, it is not huge regarding the size of videos, for example, or regarding the size of photos. But we should be able to understand the size of data that we need to register the information regarding our information system. Nowadays you see that we can buy, for example, external hard disk for 100 euro or less to 2 tera, for example. It is a huge quantity of data. When we were young, we used floppy disk. The size was almost 100, 200, 300 kilo. After that we used the floppy disk, small floppy disk, and the size was almost some megabyte. Now we can buy hard disk with tera. It is not giga, it is in terabyte. So, but we should know how we can register this data. There are some standards to manipulate the data. Usually you put the data in a database, but there is some tools to manipulate this data. For example, we have SQL language. It is a standard to manipulate the data in a database. We should know about the clouds. We hear a lot about the clouds, how we can send the data to a cloud, what type of security, where really, when we send data to a cloud, where really these data are registered. We should know about the techniques of data analysis. Now there is very powerful algorithms that enable us to understand the data with a huge quantity of data. For example, now from the behavior, if we take the consumption of water, of electricity each 5 or 10 minutes, we can understand the structure of the house. We can have a profile of the house. We can, for example, know the differences between the times and the days. There is a profile for each day, for each time in the day, for the type of people who are living, regarding the number of people who are living in a house. All these techniques are available, and there is a lot of new technology like AI, artificial intelligence, and machine learning that help a lot to manipulate a huge quantity of data and to get information, very useful information from this data. In this course, we will not be able to treat all these topics, but we should be, we will have an idea about each item. There is a lot of other techniques like supervision. In supervision, we can have a subsystem in the city, for example, water network, and we can put sensor in this network in each steps of the treatment of this system. For example, in the source of water, in the pipes, in the water towers, in the consumption, in the point of consumption, and if we put enough quantity of sensors using supervision, we can make a system to include all these sensors with very advanced algorithms and data software analysis in order to manage all these network automatically with one or two users. One user can see what happened in real time, what happened in all the parts of the network, and he can manage it and optimize this the behavior of this network. Always when we work as engineer in an urban information system, there is a very important question that we should ask. What is our goal? Is our goal to improve the existing systems, or our goal is to change these systems? Our goal is to change the technology in the system, or to change the system itself. Our goal is to find solution for some problems in the system, or to change all the system. Our goal is to rebuild the city, or to improve the traditional systems in the city. Because now the ICT, I said before, information and communication technology give a lot of availability, and if we have a strategic decision, we can change all the city together. It is not very easy to change all the city, but from strategic point of view, it may, with a limited cost, to improve all the city, comparing the cost of improving each system separately in the city to the whole system. If we can change all the system together, is easier and cheaper. So our goal is to improve each system in the city separately, or to improve the behavior of all the city together. For example, should I try to find a solution for the network of water and the network of electricity separately, or I should find a global solution for both of them? It is not an easy question because it is related to the eventual structure of the city. It is related to the governance of the city. These days, in the traditional systems are separated, and there is some rights for each establishment to manage its own city, to have a global idea and a global system about the city. We should change the manner by which we manage the city. It is not an easy question, but we should pay attention for that. I think by the time the development of each city will be related to the answer of this question. Can we have really the authority to change all these systems together with a overview, with a global overview and a clear overview? Because also perhaps the changing is very dangerous also. If we don't know exactly what we do, if there is a new system for all the city and this system is not well studied, this may also have a very bad consequence. So this is a very important issue regarding the information system of a city.